Hello everyone, welcome back to my YouTube channel. In this particular video, we are going to look into the types of neural networks. So, are you excited? Before starting with the video, I would like you all to pause the video and list down the total number of neural networks that you know in the comment section. So, let's start. So here we go. This is the list of neural networks that we have. Oh, we have more. I have listed 24 types of neural network over here. The list can be longer too. Now learning all these type of neural networks will take a decade and it's not suggested to. So why not just go and learn only the most important types of neural networks at a glance. So here are the most important types of neural networks. I have listed 10 of them. We have FNN, CNN, RNN, LSTM, Autoencoders, GAN, RBFN, transformers, self-organizing maps, and Boltzmann machines. We are going to look into all of this one by one in detail. Let's start with the very first type of neural network, which is FNN. It is known as feed-forward neural networks. This is the most basic type of neural network. Let's have an overview of it. It has a basic structure of connected layers. In the previous video, I already have given you an overview of how neural network such as ANN, that is artificial neural network, looks like. FNN has layered structure: input layer, hidden layer, and output layer. The highlighted feature of FNN is that the data moves only one way. That means from input to output. It does not move the reverse. Here we don't have any feature like memory or feedback loops. Since this type of neural network doesn't have any memory, which says that it cannot store important features. It doesn't have feedback loops, that means after every single iteration, it will not provide the feedback to the previous neurons. Feed-forward neural networks are specially used for simple classification and regression tasks. So I hope you might have got an overview of what exactly FNN are. Now that we have seen FNN overview, let us have a look at a simple example. Here the example says image classification with feed-forward neural networks. So this is how it goes. It has the input layer which will take the pixels of an image. The image will be converted into 1D array and that 1D array will be given as an input. So this is how the input layer works. Next we have the hidden layers. Already told you in the previous videos that hidden layers are specially used to extract the important features from the given input data. Next we have the output layer. This particular output layer is designed to provide the output in an appropriate manner. For example, it will predict the class in which the image falls. So this is how image classification is done with the help of feed-forward neural networks. I hope this particular simple example is clear to you all. Now that we have seen the example, now let's move on to the advantages and drawbacks of FNN. First, let's see the advantage. It is simple to implement. Yes, feed-forward neural networks are like newbie neural networks. Now as it is simple to implement, it is good for only basic tasks. This type of neural networks are best suited only for structured data. Now let's see the drawbacks of FNN. The first drawback is that it has a limited memory of data. As we have seen, it has no special feature of storing the important features. That is why it has limited memory of data. This is the major drawback of FNN. As I already said that feed-forward neural networks are unidirectional, that is why it struggles to extract the complex features or patterns from the data that is provided to it. Finally, it is not suitable for sequential data because it has limited amount of memory to store the important patterns in a given long sequence. And that was all about feed-forward neural networks. Though we haven't seen the architecture of FNN, don't worry. We are going to have individual videos of all these types of neural networks where we'll be looking into the detailed architecture as well as examples of it. The next type of neural network is convolutional neural network, which is CNN. Let's have an overview of it. Now the CNN is specialized for image and spatial data, which is unstructured data. Convolutional neural networks are extremely powerful when we compare it with feedforward neural networks in every single term. Now what makes this convolutional neural network special than FNN? It is because it uses the convolutional layers, which is used for feature learning. Basically, these convolutional layers are used for extracting the most important feature or the hidden features, or you can say the most complex features that are present inside the unstructured data. Convolutional neural networks employs filters for pattern detection. It has this particular strategy of detecting the intricate patterns with the help of filters. Now don't worry about all these terms, we are going to look into all of it in detail one by one in the upcoming videos. This type of neural network is good at handling the translation invariant features. This means that the algorithm will be able to recognize even if you shift the position of the object from any place to any other place in the entire image. This was the simple overview of CNN. Let's take an example. Again, the example is of the image classification with CNN. Here are the steps that it follows. The first thing is the input, which it takes in the form of pixels. Here you need not to convert the entire data into 1D array. The next is the convolution layers. This convolution layers, as I said, it is used to detect the intricate features such as edges, shapes and textures. Again, let me tell you, the extraction of these features will be in such a way that it will be translational invariant. The next comes the pooling layers. This particular pooling layer is nothing but it reduces the spatial dimensions. Now, due to the complex computations that occur in the convolutional layers, the dimension increases. To reduce the spatial dimensions, we use pooling layers. Now the result of these pooling layers will be the extracted features with the reduced dimensions, and then this thing will be taken as an input by the next section, which is fully connected layers. These fully connected layers are nothing but artificial neural networks which will be used to predict in which class the data falls. Now this fully connected layers will contain input, hidden and output layers. So I hope an example of convolutional neural network is clear to you all. Now let's move on to the advantages of CNN. The first advantage is that it is excellent for image recognition tasks because of the convolutional layers that it has. Next, it captures the hierarchical, intricate and complex features. The major advantage of CNN is that it reduces the need for manual feature engineering. It does the feature engineering by itself. There are more advantages of CNN. You can list down one advantage of CNN in the comment section. Next, we have the drawbacks of CNN, and the drawbacks are it requires substantial amount of data for training. CNN will require maximum amount of data for training, otherwise it won't give the best results. If enough data is not provided to CNN, then it may overfit, which means it may not be able to learn the important behavior of the data. Next, it has the limited understanding of complex context. So I hope the advantages and drawbacks of CNN is clear to you all. If you guys get any single doubt, then you can post it in the comment section. The next type of neural network is RNN, which is called as Recurrent Neural Network. This particular neural network is different from CNN and FNN. Let's have an overview of it. It is specially used for sequential data processing. Now what is sequential data? It means the data which comes in long sequence. It has a memory for past inputs. If you remember, CNN and FNN were not having this memory feature, but this RNN has this memory feature which will store the past inputs, and because of which it is used for long sequences. It is used in text or speech analysis. So that was all about the overview of RNN. Now let's move on to a simple example. The example is of a language generation with RNN. Language generation means predicting the next words. So the flow of this example goes like this. The input takes the previous words, that means the words through which the next words are to be predicted. The next section is of the hidden state. Now this hidden state will carry the context of the entire sequence that is provided. Obviously this hidden state will contain memory which stores the context. Next is the outputs which will predict the next word based on the previous words. Relate this example with the scenario where when you type something, through the context of the sentence that you have typed, the next word will be predicted. I'm sure the example is clear. Now let's move on to the advantages of recurrent neural networks. Recurrent neural network processes sequential data. As you know, it has a feature of memory, which is present in the hidden state which carries the context. Next, this particular type of neural network handles variable length inputs, which means the size of the input can be variable and it can work on it. Next, it captures temporal dependencies, which means the relationships between the elements that are present in a given sequence. The drawbacks of RNN are as follows. The major drawback is that RNN struggles with longer sequences. Whenever you consider a long sentence, for example a paragraph, in that case RNN will struggle to hold good. The next drawback is the vanishing gradient and exploding gradient problems. Due to these problems, the network becomes unstable and it becomes sensitive to even smaller changes that are occurred inside the input data. Again, don't you worry about all these terms, we are going to look into it with an example as well as with the detailed intuition behind it. The next drawback of RNN is the limited memory in practice. Now as you know, it cannot handle longer sequences. This is possibly because of the limited memory that is present in it. So I hope the overview example and advantages and drawbacks of RNN is clear to you all. Now let's move on to the next type of neural network, which is again the most important type of neural network, which is called as long short term memory, or it is commonly called as LSTM. Let's have an overview of it. It is basically an improved version of RNN. No doubt, this type of neural network is inspired by RNN, but whatever drawbacks were present inside RNN, they were tackled by LSTM. Now, LSTM deals with longer sequences very nicely. Now, the most important thing that is to be understood is that LSTM preserves distant dependencies, which is done with the help of certain concepts that are introduced in the architecture of LSTM, which was not present in the architecture of RNN. So that was all about the overview of LSTM. I hope it is clear to you all. Now let's move on to the example using LSTM. The example is text generation with LSTM. So here goes the flow. First comes the input, which takes the previous words one by one. Next comes the concept of forget gate, storage and use memory concepts. These three concepts are responsible for preserving the distant dependencies in the input data. Next comes the output section, which predicts the next word based on the previous set of words that is provided. Again, let me tell you, LSTM can handle long sequences, even paragraphs. Now let's have a look at the advantages of LSTM. The first advantage is that it captures long-term relationships. As I told you, this is because of the terms forget, storage and use memory. The next advantage is that it prevents the gradient vanishing and gradient exploding problems that were occurred in RNN case. Now since it prevents these problems, the LSTM will make the model more stable. And lastly, as you know, it handles the sequential data very nicely. So this was the advantages. Now comes the drawbacks of LSTM. The major drawback of LSTM is that it has a very complex architecture, and because of which they are computationally more expensive and it requires more amount of computation power. It also requires more amount of time to run and train due to the additional parameters and operations. It may overfit with small datasets. It requires large amount of data, and onto the large amount of data it will work the best. So I hope the entire concept of LSTM is clear to you all. If you guys have any doubt, post it in the comment section. Let's move on to the next type of neural network, which is called as autoencoders. So first, let's have an overview of autoencoders. Autoencoders are used for data compression as well as reconstruction of the data. It is an unsupervised learning technique. It has a specific structure which contains the encoder and decoder section. Basically, autoencoders reduces the inputs into compact representations. So I hope to some extent the overview of autoencoders is clear to you all. Now let's move on to the example of autoencoders. Here we are going to take image compression with autoencoder. So this is how the flow goes. First comes the input. Here high resolution image will be taken as an input. Next comes the encoder. Here the encoder section reduces the high resolution image into features. Basically it extracts the important features from the high resolution image. Next comes the decoder. The decoder decompresses the compressed image that was done by the encoder and it reconstructs the image. Note one thing, that the image that is formed with the help of decoder is only having the relevant information from the high resolution image that was provided. This is how the image got compressed. Now let's have a look at the advantages of autoencoders. They are widely used for data compression and dimensionality reduction. We already have seen one example for it. Next, it is used for anomaly detection and denoising the data. The compression technique will remove all the irrelevant things from the input data, which will automatically denoise the data. As already said, autoencoders are useful in unsupervised learning tasks, and all of them were listed. So I hope the advantages of autoencoder is clear to you all. Now let's have a look at the drawbacks of autoencoders. So the first drawback of autoencoder is that it may not capture all the important features, all the relevant features from the image or any unstructured data that is provided to it. So this is one of the drawback. Now the next drawback is that it is sensitive to noisy inputs. A little bit of changes in the data will trigger the output. If the data contains more amount of noise, then the result might not hold good. Autoencoders works the best for simple to intermediate tasks, but when it comes to complex tasks, it has a limited use. So I hope the advantages and disadvantages of autoencoder neural network is clear to you all. Now let's move on to another type of neural network, which is Generative Adversarial Networks, which is also called as GAN. This is the most popular type of neural network nowadays. ChatGPT, Google Bard is all about GAN. Entire world is enjoying the beautiful application of this type of neural network. So let's have an overview of GAN. So basically, GAN has dueling networks. First is the generator and second is the discriminator. For instance, just understand that the generator creates fake data to mimic the real one, and the discriminator will access this created data from generator and it will distinguish between the real and the fake one, which will guide the generator's improvement. If the discriminator distinguishes the created data by generator as fake, then it will again send the feedback to the generator and the generator will again create new data. So this is how the iteration goes on. This is nothing but a dueling network in generative adversarial networks. I hope you have got an overview of it. Now let's take a simple example. The example is of image generation with the help of GAN. So this is how the flow goes. First comes the generator. As I already told you, generator will create fake images. It will create fake data with the help of some randomized instances. Now once this fake data is created, it will be sent to the discriminator. Discriminator will access this fake data And now the discriminator will try to distinguish between the real and the fake data that is generated by the generator. It will give the probability, and based on that, if the probability of fakeness is more, then it will be sent back again to the generator to create a little bit real version of it, and this is how iteratively it goes on. I hope the example is clear. Now let's have a look at the advantages of GAN. So first, it generates realistic data. And this realistic data can be art, image, or it can be video also. So I hope the advantages of GAN is clear to you all. Isn't this neural network interesting? Of course it is. Now let's move on to the drawbacks of GAN. So first drawback of GAN is training instability, because the gradients fluctuates constantly and it may lead to vanishing gradient problems also. The next drawback of GAN is mode collapse. It happens when GAN generates only a limited set of outputs instead of exploring the entire distribution of the context. Finally, GAN models are challenging to tune because it is difficult to converge the model. So I hope the entire concept of generative adversarial networks is clear to you all. Now let's move on to the another type of neural network. The next type of neural network is radial basis function networks, which is commonly called as RBFN. So first, let's have an overview of RBFN. Now, RBFN neural network are used for nonlinear function approximation. It specially uses radial basis functions for the purpose of activation. Now let's have a look at the example of RBFN. Here we are going to approximate a function with RBFN. So here goes the flow. First, as an input, the data points will be taken. These data points will be random. Next comes the RBF layer, which is the radial basis function layer. It computes the distances between these data points. And lastly comes the output layer, which approximates the target function. Now this approximation is done with the help of the computed distance between these data points. Don't worry if you are unaware of these terms. We are going to look into it one by one in the upcoming videos. Let's have a look at the advantages of RBFN. It is used for nonlinear modeling as it has the ability to do that. Next, it is suitable for interpolation, and specifically it is used for pattern recognition. As you can observe, it has the ability to compute the distance, hence it can be used for recognizing the patterns. Let's have a look at the drawbacks of RBFN. The first drawback is it needs proper tuning. If not properly tuned, it will provide the worst results. Next drawback of RBFN is that it is sensitive to center initialization. And lastly, it will not properly scale when it comes to larger data. It works the best only to small to intermediate datasets. So I hope the advantages, disadvantages of RBFN is clear to you all. This was the radial basis function networks. I hope it is clear. Now let's move on to the another type of neural network, which is called as transformers. Let's have an overview of it. Transformers are attention-based models, which provides an additional focus to a particular component. It processes sequential datasets, and it has the feature of computing parallelly, as well as it has an ability to understand the context. So I hope the overview of transformer neural network is clear to you all. Now let's take an example, and the example is language translation with transformers. So here goes the flow. First comes the input, in which the source language words will be provided. That means the original statement or paragraph of a particular language will be provided as an input. Next comes the self-attention. As I already said, this is an attention-based model. Here it contains a self-attention section which learns the context, which will focus on a particular section. Additionally, it will extract the context, and finally as an output, it will translate the words into specific language. Now let's move on to the advantages of transformers. So the first advantage is that it is effective in NLP task, that is the natural language processing task. Next, it captures the long range dependencies as it is an attention based model. Next, it performs parallel processing, which improves the computation and reduces the time consumed for it. Now, let's move on to the disadvantages or drawbacks of transformers. So, the first drawback of transformers is that it needs larger datasets. Large amount of data will be used for better results. Next, it is computationally demanding, as you can see it requires self-attention mechanism, because of which it becomes computationally demanding. And the next drawback is that it is not always interpretable, which means as they are too complex for human understanding. So I hope the advantages, drawbacks of transformers are very much clear to you all. Now let's move on to the ninth type of neural network. It is called as SOM, self-organizing maps. Let's have an overview of this particular type of neural network. So, self-organizing maps are unsupervised learning technique which is specifically used for clustering the data. It maps the high dimensional data to lower dimensions, which means it is used for dimensionality reduction. Let's take an example. Here the example is data clustering with the help of SOM. So first comes the input. Here the data points in high dimensional space will be provided. In the next section, the neurons will be organized into clusters. These clusters will be randomized. And in this further section, the nearest neuron are identified as a cluster. So this is how the clustering will take place iteratively. So I hope this particular example of data clustering with the help of SOM is clear to you all. Now let's see the advantages of SOM. As you know, it is an unsupervised learning technique. It visualizes the complex data. The data exploration can also be done with the help of SOM, and specifically it is used for dimensionality reduction, which means converting high dimensions into lower ones. Now let's move on to the disadvantages or drawbacks of SOM. Now, first drawback is that it may require manual tuning. Here, the automated tuning is not possible, so therefore manual tuning is done. Many times, it happens that it may not capture all data patterns effectively. And the last drawback is that it has a limited use beyond clustering, which says that it is specifically used for clustering. So I hope this type of neural network SOM is clear to you all. Now let's move on to the last neural network, the 10th type of neural network, that is called as Boltzmann machines. Let's have an overview of this. So Boltzmann machines are stochastic neural networks. It means it incorporates randomness in its computations. It uses a special type of approach called as energy-based approach, which is used for model data distribution. So I hope the overview of Boltzmann machines is clear to you all. Now let's move on to the example of Boltzmann machines. Let's take an example of image generation with Boltzmann machines. So here goes the flow. First is the input section where the random data is provided. This particular random data may contain noise. Next, this particular data uses energy-based approach which learns the energy landscape of real images. So basically it will construct a distribution for it. And next it generate new images that matches the distribution. So this is how the image generation will take place with the help of Boltzmann machine neural network. So I hope to some extent it is clear to you all. Now, after the example, let's move on to the advantages of Boltzmann machines. So here comes the first advantage of Boltzmann machine. It captures the complex data relationships. It captures the intricate and the most important features between the datasets. Next, it is very much useful for unsupervised learning techniques. Now that we have seen the advantages of Boltzmann machines, now let's move on to the drawbacks of Boltzmann machines. The first drawback is that it trains the model very slowly. Next, it requires specialized techniques for executing a particular task. And the last drawback of Boltzmann machine is that it is not as widely used as other models that are used for this particular purposes. So I hope this type of neural network, Boltzmann machines, is clear to you all. Now with this, we have covered the 10 different types of neural networks that are most important in the field of deep learning. I hope every single concept that is addressed in this particular video is clear to you all. If you guys face any single difficulty in understanding a single silly concept, then please put it in the comment section. I'll be really happy to solve all your doubts. With that, also post your suggestions and reviews regarding this particular video as well as for the upcoming videos. Please share this video as much as possible with your friends, family members, so that they will also get benefit out of this. And for more such videos, do like, share and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Also join me on Telegram channel. Thanks for watching. Have a good day ahead.